Okay, so have you ever stopped and wondered what really makes things move? I mean, we see it every single day, right? A ball flying through the air, a car starting up. But what's the actual physics behind it all? Well, let's dive in and figure it out.
Think of this as a little investigation. We're on the hunt for the secret behind all motion. What is this invisible power that gets things going, brings them to a stop, and can even make them turn a corner? It's time to look for some clues.
And our first clue? It's literally everywhere. You say it when a soccer player just unloads on a ball and sends it flying, or when a cricket bat connects and bam, the ball's direction is changed in a blink. In both of these moments, something big is happening to change what that ball is doing.
And it's not just about sports, Think about a stalled car getting a big push to get going. A kick, a strike, a push. You're probably seeing the pattern here. They are all different flavors of the exact same idea.
And this brings us right to the main character of our story, the culprit behind every single change in motion. It's time we officially meet our number one suspect, something we call a force.
So in physics, a force is, well, it's just a push or a pull. That's it. Seriously. Every single time something speeds up, slows down, or changes direction, you can be sure a push or a pull is behind it. And we measure how strong that push or pull is in a unit called the Newton, named after a guy we're definitely going to be talking about in a minute.
So what can a force actually do? What are its superpowers? Well, it can get something moving from a complete standstill. It can stop a moving object dead in its tracks. It can speed things up or slow them down, or make them take a sharp turn. Heck, a force can even change an object's shape. Think about the force from your hands when you squeeze a lemon. It's basically the ultimate agent of change in the universe.
But, okay, here's where our little mystery gets a bit more interesting. Because in the real world, a force almost never works alone. Most of the time, objects are stuck in a constant tug-of-war, with multiple forces pulling and pushing all at once.
Take a look at this basketball. It seems like it's just chilling in the water, right? But it's actually in the middle of a serious fight. You've got gravity pulling it down, trying to sink it, while at the exact same time, the water is pushing it up. It's a perfect standoff.
And this leads us to the most important question of our whole investigation. If pretty much everything has a bunch of forces acting on it at once, how do we know what's going to happen? Who wins the battle? And right there, that question leads us to our big breakthrough moment. The answer to who wins all comes down to a really simple idea: whether the forces are balanced or unbalanced.
Let's look at a classic game of tug-of-war. In this picture, both teams are pulling with the exact same strength, just in opposite directions. So what happens? Nothing. The rope isn't going anywhere. It's a complete stalemate. This is a textbook example of balanced forces.
But look what happens now. The team on the left is clearly pulling harder. The forces aren't equal anymore. They've become unbalanced. And the result is immediate. We have motion. The rope and the team on the right are getting dragged in the direction of that stronger force.
So here's the bottom line, the key takeaway. When forces are balanced, they just cancel each other out. Nothing changes. If an object is still, it stays still. But when the forces are unbalanced, you will get a change in motion. It's as simple as that.
And physicists have a special name for the final result of this whole battle. It's called the net force. You can think of it as the overall final force left over after all the pushing and pulling is done. And it's the net force and only the net force that decides what happens next.
So how do we figure out this net force? It's actually just simple math. If forces are on the same team, pushing in the same direction, you add them up. If they're fighting each other, you subtract the smaller one from the bigger one. So if one tug-of-war team pulls with 10 newtons of force and the other team pulls with only 8, the net force is 2 newtons and the winner is clear. That little calculation tells you everything you need to know.
All right, we have all the clues now. We know that forces change motion, and we know that the net force is the ultimate decider. It's finally time to solve this mystery once and for all with one of the most powerful laws in all of science.
But first, we've got to give a shout out to the guy who paved the way. Before Newton, the incredible Galileo Galilei had this thought experiment. He imagined a world with zero friction. He realized that if you slid an object on a perfectly smooth surface, it wouldn't ever slow down. It would just keep going, forever. This was a mind-blowing idea for his time, and it set the stage for our grand finale.
And here it is. Sir Isaac Newton took Galileo's incredible insight and wrapped it up perfectly in his first law of motion. It ties everything we've talked about together. An object will just keep on doing what it's doing, whether that's sitting still or cruising along, unless it's acted on by an unbalanced net force. See? It all comes back to that net force.
Newton even gave a name to this stubbornness of objects to change what they're doing. He called it inertia. It's just a natural property of stuff. And the more massive something is, the more inertia it has, the more it resists change. It's exactly why it's way easier to push an empty shopping cart than it is to push a car. The car just has way more inertia.
And that brings us full circle, back to Galileo's idea, with one last thing to think about. What if friction, that force that's always slowing things down around us, just vanished? What would our world be like if once you got something moving, it never stopped on its own? It's a wild thought, but it really makes you appreciate these invisible forces that are secretly running the show, all day, every day.